My name is Farah Capital Alpha and my meeting number is BE19081. So we are from Group 4. So for our project, we choose about the FIR, Finite Duration Impulse Response, and IIR, Finite Duration Impulse Response Filter. And for the FIR, is a finite duration unit response, and the unit sample response is for duration from 0 to m equal to 1. And the FIR system are non-recursive, means the output of FIR filter depend open design and pulse input, while the IIR system is infinite, duration unit sample response, and the unit sample response exists duration 0 to infinity, and it the recursive, and it also used for feedback, and the output of IIR filter depend the present and pulse input as well as a part of output. So for the more understand, I will show you at the previous video. Okay, the following animation is shown the process of how the gain factor equivalent to the coefficient of the input response. The idea is the FIR filter is to connect to the input delay and the filter to the series delay. And the first one with only the small sample delay, and the second and one with two, and so on. After that, the amplifier with the gain factor set for the delay and finally delay output and merge together. So you can see the output IR is like that. Okay, now for the IR is using the delay of the input value of the filter and also the value to the output impact and then delay change and feedback back to the signal to the input of the filter. So you can see and here after the gain to the delay.
Assalamualaikum, my name is Muhammad Nabil bin Mat Fauzi, my metric number is E19003. Today I will continue the presentation about the literature review. The FRI filter design over a discrete powers of two coefficient space has long been a topic of activity. The publisher has published the first written work on this topic, signal processing. Several articles of issues paper were renewed as part of the sixth literature review. And for FIR, low-pass filter designing using different window functions and their comparison using MATLAB on their research paper. Okay, for the another study conducted, the publisher is on response analysis of FIR high pass filter design using window methods. And in addition, in a published paper on FIR filter design by another publisher, a modified window function is a Hamming window function where used in the design, and the frequency response on the modified window function and the Hamming window function was shown in the simulation result, with the modified window function providing the most efficient and best design. The optimization of a set of filter coefficients that meet various filter specifications such as pass band width and gain, stop band width and attenuation, as frequencies of a band and stop band, peak ripple in a pass band and stop band, and linear phase response in a band and transition band is required for digital infinite pass response IIR filter design. Next is common segment. Infinite duration impulse response IIR filters have zeros and poles, hence they use less memory than finite duration impulse response in FIR filter, which only have zeros. IIR filter can be difficult to construct and delay and distort modifications might change the pulse and zeros, making the filters unstable. FIR filters, on the other hand, stay stable. There is no feedback mechanism in FIR filters. Their current input consists solely of current and previous input values. The output of IR filter is a sum of unit number of unique samples of input values. For applications that demand a linear phase response, FIR filters are better. These filters have recursive due to inherent feedback mechanism. Then they never let an apply impulse cause their response to drop to zero. They are more efficient in terms of computation and memory usage. They are, however, less stable and difficult to govern due to their recursive nature. Next is objective. First, to pursue the signal in Z domain. Number two, to produce spectrum from a signal using Z transform technique. Number three, to represent the filter system which use Z transform technique. Next, to use the digital signal processing technique. Then, for another point is to present the output signal of a system using convolution technique. And lastly, to get the knowledge of FIR filters theory and concept. Okay, that's all for me.
Hello, Doctor, and good morning. My name is Ming Bit, and I'm from Section 2, Group 4 for the DSP, which is Digital Signal Processing. And today I'm gonna present is for the better methodology. So in order to perform the filtration system that estimate the spectrum based on Z transform, To solve the problem, we must first calculate the output signal of a system using the convolution approach. We must first encode the signal in frequency domain using discrete Fourier transform methods before we can visualize it. That transform is then used to transform a discrete time signal, which is made up of a series of real complex values into a complex frequency domain representation. So this is the flow chart that I do. First one will be start, and the second one will be write the command for the t and s value, and then put the given value of amplitude and plot the graph and end. This is the flow chart, and the next one is the strategy and approach design. In this assignment, since the analysis any sample signal or sample data system in the frequency domain is extremely difficult to using Laplace transform, because the signal or system equations will contain infinite long polynomials due to the characteristic infinite number of poles and zeros. So we will use Z transform technique in order to reduce the poles and zeros to a finite number in the Z plane. So this is the infinite impulse response filter, and this is the formula to get. And the next one is finite impulse response filter, FIR, and this is the formula. So the next one is the software we're using is MATLAB software here, and the next is the MATLAB interface. So this is the MATLAB interface of our assignment. So that's all for my presentation. Thank you.
Assalamualaikum, my name is Mak Farhan bin Akbar Shah, matric number DE180130. I'm going to be presenting about the result analysis for this project. So first we're going to talk about the finite impulse response FI filter. The result of origin signal, which on the left side is with a sampling frequency which is fs equal to 100 Hz. And the magnitude and phase spectrum of this original signal is with the same sampling frequency which is fs to 100 Hz. The difference of the original signal and filtered signal can be seen in the picture above. Here is saying the difference, which is after the signal passed through the filter, interference of the signal has slightly reduced from approximately 1 to 0.996496. This is due to the Hamming window technique and ideal low pass filter. The difference is about 0.003. So next is this picture shows the response of Hamming window. The magnitude and phase response are displayed in this picture, and the picture shows that Hamming filter reduces noise from the input audio of the original signal. Next, I'm going to show you the simulation. Here are the MATLAB coding for FIR. As you see here, this is the data from the Excel, and this is the first plot for the original signal, and the magnitude and the phase spectrum. So now we're going to run all of this coding, all of this codes. So as you see here, the first one is the original signal from the given data, and the second one, this magenta color, is the process signal, the filtered signal, and here is the magnitude response of the signal. So next one, we're going to continue to the infinite impulse response, which is IIR filter. The picture on the left shows the original signal with sampling frequency fs equal to 200 Hz. Defines the original signal with 20 samples. Magnitude and phase spectrum with the sampling frequency fs 200 Hz before using IIR signal. Picture on the right shows the filter signal after goes through the IIR's elliptic filter. The interference signal has been reduced from approximately 1 to 0.708176. So next I'm going to show you the simulation for IIR filter. So this is the code for IIR filter, and I'm going to run it now. Okay, here is the original signal, which is the blue color. The green color is the filtered signal, and this is the magnitude response of the filter. And here shows you the magnitude response along with the passband edge. So that's all for the design analysis part.
FIR filter generate an output of the mini system using the sample of present and past input value, while the IR filter is the present and past input value amount with the past output value to generate the present output. So the IIR filter generate just for application, while linear pace is not important and memory is limited. So now I have the ASM filter design. provide the engineer with the important everything that need to design, experiment, and develop complex IIR and FIR digital filter, a variety of the sensor measurement application, and the advantage of coupled with automated recognition and code generate functionally can make the engineer design and validate either IIR or FIR digital filter. Just a minute, compare the authors make the hours to settle about that. So that's all from our group. Thank you.